Now just imagine we are in third day. The one machine which has got the highest setup time is free. It has already done its work. Okay, let's keep running. Do we have, let's check, only one stock left? Yes, there's no inventory available. There's no inventory available. The reason why this inventory is not available is because this one took away one extra from our plan. Now we can't do anything but move this here. Okay, now we are set. This is looked after because there's enough running. I need a blue immediately. When this blue stops working, I have to shift here, otherwise this line will not work. Okay, it's running fine. Day 4 over. Day 5 running. Yes, my dispatches are taking place. This one is a problem. The moment my inventory here goes down to 0, I will allocate blue to this process and this line will be fully loaded. Right? Yes, perfect. As per the plan. The moment this goes idle, boom, this is idle, I move it here. Just imagine my control. I am able to move my machines from one process to second without delaying. That means my information system is also very good. I am not blinded from a shop floor, and that is why this is an ideal situation. Okay, and I think till now we are doing a good job. Okay, because we haven't wasted any time in reallocation, and till now everything is going fine. I'm on the 4th day. 7 hours 45 minutes have been used. I still have one more day and my process is working. End of the day throughput. Let us check. Right, this is satisfied. Now I will move D9 to this place so that a dispatch happens. What else is idle? Yes, 2 of the purples are nicely allocated. Light blue is working, green is working. Now I can't do anything. Wait and run. Since I can't do anything, I just increase the pace to full pace so that we save much less time. End of the 5th day. The simulation has ended. Here is the display. I have not been able to supply 1 for A, 8 for this F, but my net profit is 4,000. End of the week cash has gone up. ROIs, throughput is good. Sales have been nice, and the RM inventory is 1235. Let's look at what we have done with our performance of managing my resources. 90% of my time for blue got used up for production. Green 36% of time. Let's take a look. Green was a resource which seemed like a problematic resource because it had this huge setup time. Okay, but when I look at it, only 36% of it was used for production, and we did pretty well. Cyan, which is nothing but the light blue, 9% was used for setup, 56 for production. Going back to green, 13% of the time was used for setup and 36 for production. So what we see here is blue is my most heavily loaded resource. Anyway, this is how this simulator is used. It's an ideal situation where you can get the information of what is happening on the shop floor to you instantly. The squares are inventories, the rounds are resources, the colored round are resources. The other rounds or elliptical ones are either raw material or finished good. Every data information is coming to you instantly. When a machine starts, it does. You have the right to stop it and change it. There's no rejections. And even after that I missed out on sales. Let me look at a plan. Okay, let me look at a plan which has been already designed, and I'm loading it. When I say I'm loading the plan, that means I am saying that I have a predetermined schedule, and when I load that schedule, I am very confident that I don't need to do anything. That is my confidence. So I increase it to 6 space. I say run. Blind. The day ends, I close the window, run for the next day. Mind you, this is not much different from my previous run. Right? It seems so. Okay. Run. The plan is so good that I don't have to interfere. This is what is called management attention. It is planned in so much of detail that it hardly requires you to intervene, and that's what I meant by loading the plan. In that plan, it has been told to you on which date and which time will you change over. In my other simulation, I was using my eyeball to control my setup change. That means when I saw a machine go idle, I said stop and I changed it. But here I am doing the same thing, forcing a changeover by simply planning ahead. And I'm so confident that I'm good that I don't even bother to go back and take a feedback from the shop floor to say what is happening to the machines. Here I finished the whole week and look what happened. Oh my God, I've been able to sell everything. What happened? Here the setup time for green has gone up. The production time of blue has gone up. So what we see is, as the production time for blue has gone up, so has the sales. That means blue is very closely related to the increase in sales. Now, how do I find this out? To find out what or which machine is going to limit my production, or which is going to be the most heavily loaded machine, I need to do what is called an analysis or a rough cut capacity plan. Here is a tool to do a rough cut capacity plan within the simulator. It just says please put all the demand is and press analyze. It will tell you which machine is loaded for how much minutes and what is the capacity. So here, by looking at this rough cut capacity plan, we are seeing that the blue resource is going to be loaded for 94%, green 33%, cyan 56%. Now we know that if we control the use of blue resource, my output is going to be controlled. Any loss or any mismanagement of blue is going to be loss of throughput. And this is what we landed up doing in the plan. When we loaded the plan, it made sure that the blue doesn't go idle. It does not matter which product you start from. What matters is you should have a detailed plan for the blue. And that's what we did. We didn't waste a time. We started loading this one, blue. Why we loaded blue? Because there were 25 units of inventory available where it could start. If I start my week today and I use this or this, all of them had inventory in front of them. So it didn't matter which blue, but the plan for blue was the most important thing to do. We made a bit of mistake because we were haphazard, we were all over the place. Our plan worked because we focused on the blue. Now, coming back to more policies that we are using in our companies. It is the same operation. In the name of efficiency, we start putting batch size. In this simulation, there was no batch size limitations put. That means we said as and when one unit got worked upon, it was transferred to the next resource. However, such a thing is not very easy to be found on any shop floor. There are always bins, and there's always a lot size. There's always, you can say, a material handling equipment, and that material handling equipment is only moved when it has been fully loaded. So in this situation where we were able to meet the whole demand, where few of our policies were not implemented, that means the batch size was not done. What else was not done? The utilization of many resources were not measured, because I could have said in the beginning of the month, why is my brown not being utilized? The brown was not being utilized because the green was still not producing. Now, in a bid to make sure that the brown got loaded, I would have made a mistake. Or in other sense, if there was an inventory lying before any other resources and I would have loaded the green, in the sense, instead of blue, I could have loaded green here. Why? Because green has got a lot of setup time and it shows very low on my performance, so I could have started here. The moment I load green, I've made a mistake, because green actually has a lot of free capacity available, which my analysis showed. So I didn't use many of the local utilization efficiencies, etc., which is our measurement for performance. I could have done it. However, let's not look at all. Just look at one of the policies called the batch size policies, which is so common in many plants, or rather it exists in most of the plants. Here is the plant now, and what we have done right now is implemented one policy called the batch size policy. In the simulator, if you press info, it tells you everything. That means the information behind most of the round boxes. So here $180 is the selling price of the product A, $240 is the selling price of product D. Similarly here, what you're seeing here, B is equal to 20, B is equal to 20, B is equal to 20, is nothing but we have now implemented one of the local optimization policies called the batch size policies. The same plant layout, the same process, the same product, which initially we were only able to miss 9, and then when we put the ideal plan in, we were able to dispatch everything with certain capacities of resources available. I am going to use the same plan, but in this run I have just implemented my batch size policy, and the policy is every batch will be of size 20, and only when 20 has been produced will it be moved to the next station. I have not yet forced my people to make sure that the utilization of all my resources are very high. I'm just working from the cost world, and I'm saying that if I have a resource and if it is lying idle or it is under setup, I'm losing money or it's costing me money. To avoid that, I am now going to make sure that I reduce the number of setups and increase the batch size. This is one of the policies. Mind you, this is the same environment. That means the vendors can supply you the material whenever you want. The customers don't change their mind, and the quality is fantastic. That means there is no rejection. The rate of production is constant. There's hardly any absenteeism, and you have a perfect feedback of what is happening on the shop floor in front of you. And above all this, you can always stop the simulation and take a decision and start the simulation. Now here is the same plant. Now I get rid of info. I load the same plan. That means I will purchase materials this way. This is the sequence in which the blue will operate, and the green will also operate this way. It will first work at A5, then it will go at A5 again. It is on fully automatic. I am very confident, as I was in the last run. I am going to unfreeze. The moment I run, the clock runs. Everything is planned perfect, because in my last run with the same plan I was able to send out everything. Here I have the same plan, but now I have introduced the batch size. What you're seeing below this square is the batch. The moment it processes 20, then only can it move. So if you see a number, that is how it is processed. The moment is 20, it gets transferred. Okay, day 2, still no throughput. Let's go to day 3.